Hello all. Today's video is regarding the demo of the container manager which I was speaking in my previous video. So this demo is regarding version 0.7.3. If at all there are any feature releases of this particular repository, maybe if possible I will create more videos. But as of now it is for 0.7.3, which is the latest release of container manager. So as I discussed earlier, the container manager is a MIT licensed completely C++17 application which basically supports multiple protocols like REST MQTT, message queue, dbus, gRPC is under consideration. Apart from this supports the CLI and API based triggers. As of now, the container runtimes are Docker and Podman. I have plans of K3s and Bluechy going forward, but yeah, that depends on the amount of time which I have. And on top of it, it supports even the YAML files also. I mean the YAML formats for creation of pods. And in the same case, the data type which it supports as of now is JSON and protobuf. And on top of it, the security encryption decryption which is supported as of now is AES 256 and SHA-20. This is what it is currently doing. And apart from this, a heartbeat server has been integrated into this particular application, so that in future if anyone wants to integrate it with any of the standard monitoring applications like Grafana or Prometheus or whatever, they can easily do that. And the main point is this particular container manager does not serve any purpose as of means directly. It is not how it works. It is basically an architecture which basically gives you the flexibility to implement your own business logic as quickly as possible. It basically standardizes most of the standard parts, and it leaves the business logic for any developer to clone this repository and tweak this project as per his requirement. So that is the main idea. Okay. If you have any doubts, you can please refer to my previous video. I will anyways add it in the description of this particular video. Now getting into this particular project. So this particular project is structured, and this is the folder structure. So we have multiple folders over here. The first folder over here means we call the application as app, the container manager, and it has the application API folder which basically handles all the protocols and the heartbeat server. This is what it is, and any future protocols will be basically incorporated over here only in API. Core is basically the business logic, which is the service layer. So as of now, it receives and it operates accordingly. There is no extensive logic in the over here. As of now, its only job is to receive the requirement whichever comes in via in the form of a Python UI for our own quick testing. But in reality, it will happen via an OTA gateway, or it could be happening via any other third party, or sorry, I mean to say any other service in the vehicle. So this is how it is, but for now we are testing it out with the Python UI. And the logic over there is nothing much. So you basically get a piece of information via any of the protocol. It can be or it may not be encrypted. So the job of this particular container manager is to basically receive the data, decrypt it, and execute in the corresponding runtime whichever is asked for, and at the same time saving the data in a corresponding database as per the choice. As of now, the database which is supported is Redis, and we have an embedded custom embedded database, so we can just swap it with whatever database we want. And as I said, the data formats are JSON protobuf. This is in the executor folder, so you can add any other database, any other data type if at all you want to add in future over here. The current runtimes which are supported are the Docker CLI, the Podman CLI, the Docker API, the Podman API, and the Podman YAML. The Podman YAML API is not supported yet because the Podman version which I am using is 3.4.2, and the Podman YAML API is available only from Podman version 4.2. So yeah, that's the problem. If going forward, I'll try to upgrade my Podman and I'll try to incorporate that as well. And utils is basically where we have the thread pool. As I said earlier, each protocol has its own separate thread, so that there is no much of a lag. And on top of it, the heartbeat server runs in a separate thread altogether, irrespective of what protocol is running. The heartbeat server is written in HTTP so that it can be easily integrated with any other third-party application like Grafana or whatever. And here is where the logging mechanism is also integrated in this utils folder. As of now, it is STTC out or it is glog. If at all you would like to have any other logging mechanism, you can add it over here. Everything is in interface. You can quickly add whatever you want without disturbing the existing code base. That is how it is designed. And regarding the security, as I said, as of now it is AES and SHA-20, and there is null security, means there is no plain text, no security. So these are the three things which are supported. You can have whichever algorithm you want, also you can have it over here. The main.cpp is the actual entry point, and third party folder is where whatever libraries which I am using, they are part of this particular third party. So this is how the code is structured. And coming to the flow, these are the 4 protocols which are supported as of now: the REST, MQTT, message queue, and dbus. The data the job of this protocol is to simply receive it and send the data forward. Just forwarding to the data to the executor layer. So over here, the data can be either a plain text or in an encrypted text. In case of dbus, it's a base64 encrypted. And once this data comes in, then it is the executor's job. It could be either a JSON executor, or it could be a protobuf executor, where it receives the particular incoming data, decrypts it if at all it is encrypted, and change the format if at all it is a serialized data in form of proto, and then convert the output, or convert the incoming data in form of a JSON in either of the cases, and forward it to the container service handler. So here is where the as I said, in the container service handler, this is the place where the business logic is written. As of now, it is not extensive because it is only a dummy application for now. It simply receives this particular incoming data and routes it to the corresponding container runtime, whichever the user has asked for. It could be Docker commands, or it could be Docker API, or whatever it is. Means if at all, say the selected format is Docker, and you just want to see the list of images, then it runs over here Docker ps -a. If at all it is a Docker API, then the corresponding API for this is triggered. That is how this is handled. And the once all these operations are done, all these are logged. So the database handler is another interface where, as of now, Redis and embedded database are supported. So it goes to the corresponding database which has been selected. And at the same time, this is the container runtimes which basically are supported as of now, Docker and Podman. And this is the sequence diagram which I have explained just now. Say the incoming data is a encrypted JSON. So from the client, it goes to this particular REST server, which is over here. Means this particular REST will be on, the API will be on. It receives it, then it basically goes to the JSON executor. It detects the encryption and it decrypts it. Say the build is done only for SHA-20, and if at all the incoming message is AES encrypted, then it will not be decrypted. Only if at all it is SHA-20, then only it will be decrypted. So then say the incoming is SHA-20 and the build is with SHA-20 only, then the decryption happens and a JSON is generated. The JSON is basically sent forward to the container service handler. This is what I was speaking earlier. And from here, via the command pattern, where based on the corresponding command, it is routed to the corresponding runtime, whichever it is, and the data is saved in the corresponding databases, whichever has been chosen, or which this build has been done, and the result at each step is basically sent out. So this is actually the ideal flow. Okay, now let me show you a small demo so that you can understand. This is the repository. The link for this repository will be in the description, and this is the 0.7.3 release. everything is written in C++ only, and this particular piece of Python file is for the UI. The description, the readme is elaborate, and apart from this readme there is an architecture document also. In the same particular, if you scroll down, you can find architecture somewhere below over here. If at all you go, it goes to this particular architecture where it sees where it explains with respect to what is the architectural patterns which have been used, how each of this protocol works, and how the thread pool works, everything, how the error handling is done, everything has been explained in detail. And this is the system architecture. This is the folder structure which I was explaining about. This is the various design patterns, various folders, why they exist, and all of that description. Apart from that, what to say, yeah, so this is basically the documentation, and on top of it, Doxygen has been integrated. So this is basically the Doxygen related files. All of these have been version controlled into this particular folder itself, in this repository itself. So if you go into docs, you will get the Doxygen files which I was showing just now. And apart from this, there are two videos. These two videos are nothing but regarding why this repository exists in the first place and how it works. So these are the two videos which this is basically the part 1, this is basically the part 2 which we are recording right now. So this is the Doxygen details, everything is there, the class diagrams, everything are already there. So this is the overall project documentation, and now let's get into the demo. So this is the CMake, the main CMake list.txt, where we have multiple flags. Each of this flag is used for selecting and building a specific build as per our requirement. So if at all you see over here, if at all I want rest, then I have to enable this flag. If at all I want MQTT, then I have to enable this flag. And for this particular flag, these are the corresponding libraries which are needed, which has to be installed so that you can build it. So this is the entire table, and this particular CMake list is corresponding to that only, like the corresponding flags and what it does. And this is basically the security algorithms. At any point of time, there is only one security algorithm which is allowed. And this is the main file. In the main file, based on what particular flag is set, the corresponding header file is included, so that it gives you a lot of flexibility while you are building it. And it removes lot of overhead with respect to the unnecessary binaries getting into your main application, so that it becomes light, and it has less attack surface with respect to the security point of view. And I was speaking about the YAML format. If at all we want to create a pod, and also this is the YAML master.yaml template. This is basically a template. You can change however you would like. I'm just keeping it as simple as possible. The incoming data will be filled into this particular template, and we can basically create a pod, delete a pod, do whatever we want. So I will show you as part of this demo as well. And apart from this, these are the security keys for AES and SHA-20. Ideally, this is not how the file should be present, but as it is not a production system, because in production you will have it in a separate folder, secure location and all. This is this is an example. We are not productionizing, so I just kept it so that it is available for anyone to tweak and play around. And this is the folders which I was speaking earlier. So we have the corresponding just a moment, let me show you. Yeah, so the corresponding protofiles and everything are over here. So this is the protofile which I was speaking yesterday, in the previous video. These are the proto generated folders and all. These are the file format, the data formats whichever are supported. Similarly, the APIs which all are supported, everything over here. You can add whatever you want as per your requirement. And this is basically the UI. Here also we have the protofiles, because if at all we have to send the format as a proto, then basically we need it. And yeah, this is the UI, and these are the Doxygen files, nothing fancy over here. So let us get into the demo. Now let me build the application keeping all the features enabled. I'm clearing my CMake. Now that it is done, I am enabling the REST MQTT message queue dbus. I have switched to protobuf. I have switched to encryption is on. Redis, I am using the database as Redis, and SHA-20 is the selected algorithm. So let me just build with this. Let me do a make clean. Let me do a so by the time this build is done, let me just show you the UI. So this is the UI. So here you can see that I can choose between the data formats whichever I want. I can choose with respect to what I want to do. I want to create a container, start a container, stop a container, restart, remove, or and I just have to check whether the container is available or not. Whether it is whether the data incoming data is not encrypted, AES encrypted or SHA encrypted, or what is the protocol. As of now it is REST MQTT message queue and dbus. And what is the runtime? Is it like Docker CLI, Podman CLI, Docker API, Podman API, and Docker YAML? If at all I choose Docker YAML, there are only two things: either you create a pod or you remove a pod. There is no starting a pod, stopping a pod, pausing a pod, and all. And these are the CPU parameters, like if using the C groups and namespaces with respect to how much resources you want to restrict for the corresponding container or pod. This is the thing, and these are the ports and all, the restart policy, etc, etc. And you can see that the dot over here is red. It indicates that the backend system, means the container manager, is not up. That is what this particular dot indicates. So how it does is, this particular application runs has a separate thread where it tries to ping the container manager every 1 second at port number 8090, which is customizable. You can add whatever port number you want, and if it doesn't receive a response, then it is red in color. So the build is done. Now let me run this. So when I run it, you can see that this particular application has turned green, so it means that the container manager is up and running. Now let me just show you that there are no containers running. Now let me select Docker, let me select REST. The data format which we built with is actually proto, and the operation which I want to do is I want to create an application, and the algorithm is SHA-20. Okay, now this is the application name, the container name. Now let me just send a request, and now let me do a docker ps -a. You can see that the container has been created 2 seconds back. Let me just check its status. So the status is created, but it has not yet started. So now let me just switch it to MQTT, and the operation I want to start it. Okay, so now when I click on start, the application is starting. If at all I go to the Redis database, you can see that the Redis database, earlier there was nothing. Now the incoming runtime is Docker, and the status is running. This is the container which is running. Now let me just go to message queue. Let me say stop, and instead of Docker I will do a Docker API. Same thing, instead of a CLI command I am doing an API command. Okay, now let me just send it. It has been sent. Now let me refresh it. You can see that the status is stopped. The command is Docker API, and if at all you can see, yeah, it has stopped. Okay, now I can click on, if I click on health, it will basically give which are all the features which are enabled in this during this build. What is the port at which this is running, what is the version of this particular application, how long this application is on, what is the timestamp, everything. Okay, so this is what it is over here. Now let me switch to dbus. Let me just keep it as Docker API only, and let me click on restart. Okay. Now if I click on restart, you can see that this particular application has started again. Okay. Now let me go back to, in reality you will not switch the algorithms, like for your application you choose any of this algorithm, but in this experiment I'm just showing you the capability of this particular application regarding the various supporting algorithms. So that is the main idea, but in reality this is not how it will be. You will specifically choose which algorithm and which particular data format and which particular encryption, so that you will target only to that. The next example I will show you that also. Okay. Now let me just switch back to rest. Let me just, I can switch back to Docker, and I can say that I want to remove this application, and the data format is proto, and let me just send it, and you can see that this particular application has been removed. I mean, like, if this particular container has been removed. Now if at all I do docker ps minus -a, it is gone. Okay. Now see, if at all I refresh, I have to refresh everything is gone. Okay. Now let me do one thing. Now that we have seen that this is how the container manager works if everything is enabled, let me try to give a minimal build. What do I mean by that? Okay, let me just remove everything. Now I want to do a CMake, and I want only MQTT to be enabled, nothing else. Okay. And when this is done, you will basically be able to see which are all the features which are enabled. Yeah, so the build is done. So here you can see that only MQTT subscriber has been enabled. We have not chosen proto, so it falls back to the default, which is JSON. We have not chosen Redis, so it falls back to the embedded database. And we have not chosen any algorithm or any encryption, so by default it is not encrypted. Nothing is there. Okay. Now say now you can see this. Now if I click on health, you can see that everything is false except the MQTT. Okay. And now what I do, let me just change the data format to JSON. Let me click on create. There is no SHA. Let me just put it on none, and say I want to run the same request of creation using Docker. Okay. Now if at all I send, it says that there is no server running. This port number 5000, nothing is running over there, so this is not possible. Okay. So I have to choose the MQTT, which has been enabled, and now let me just send it. Okay. Now this is successful. Now you can see that it is created, and yeah, here it is on. Okay. Now I cannot switch to any other algorithm, only MQTT. This is how things work. Both the Docker and Docker API works. And say if I send something like an encrypted data, okay, I want to start. Okay. Now if at all I send it, in the build you can see that the JSON parsing has failed. The decryption does not happen. Okay. Now let me revert back to start only, but there is no encryption. So let me now just send it. You can see that the particular container is up and running, and if at all I take you to the Redis database, I refresh, nothing is there, are no entries, because we are not we are just having our own on memory database only, which we have created, and there is no Redis anywhere, so there are no entries. Okay. So now let me just remove this particular container, whichever is running. Now let me just send it across. Okay, fine, the container is removed. Now what we do is we switch to Podman. Okay, and we create a container using Podman. Now if I do Podman ps -a, you can see that there is nothing. Now if at all I do a create using Podman ps -a, now see, a container is up and running. Okay. Now similar to Docker API, the Podman API also works. Now let me just quickly remove this particular container also which we have created. Now the container which was created by Podman has been removed. Okay. Now let me do one thing. Let me switch to Podman YAML. Okay. In this Podman YAML, basically I would like to start the pod. Okay, this is what I want to do. Now yeah, now you can see that the containers are up and running. Sorry, the pod is up and running. This is basically the pod which has been created. Now I want to remove it, so it is the same Podman YAML. And now if at all I send it across, so it basically creates a file like this. It takes the master template, it takes the incoming data, and it fills wherever the data is not there. Okay, and these are the parameters with which the Podman the file has been created. Okay, this particular file I wrote it and I saved it for our own explanation sake. In reality, this is not how it will be, because only the master template will be saved in a string. The string will be appended with the corresponding values, and it will be simply run as a string only. This particular YAML file is not required. And now just let me just remove it. I have sent it, and now if I do a pod ps, the pods are gone. Okay, so using this particular what do I say, using this particular repository, I mean like this repo, you can jumpstart your application, the container based applications whichever you want to deploy in your car or whatever it is, so that you can actually work on the business logic, create value, rather than working on the same fundamental blocks again and again. So that is the main idea regarding this particular project. Thanks a lot for your time, and yeah, have a nice day. Thank you.